That was totally what were you doing? That was
Oh, long big out with you.
Mr. Alger, Jeff found a sharp pencil.
Well, you're having almost as lucky a day as Christian. Okay, you found $20. You have a piece of paper. Hey, James. Hey, notes. Austin, notes. Okay, this is the last section in the chapter, and so that means that before too long there will be a test in your future. Certainly won't be on Monday. Okay, we'll probably do a review assignment Monday, maybe practice test Tuesday, and then have the real thing on Wednesday, something like that. Okay, and this is a weird section to end the chapter with because it seems like we have done this before. All right, but it's there, so we'll just make our way through it anyway. What this is all about is this time using proportions with parallel line segments. So is that parallel?
Sure.
Close enough? Okay, so here's what this is all about. Okay, and there is a what? Right, there you go. Good point. It doesn't matter how I draw those lines. As long as the little arrows are there, then you know that they're parallel. Okay? How many triangles do I have on that diagram? Two. Got the little one. No, I don't have three. And that's very important for you to understand that. That's going to come into play in a little bit. Okay? This right here, this right here is certainly a triangle. Okay? Hey, listen please. This right here is certainly a triangle, all right? But do not be fooled into thinking that this is a triangle right there. What's that if those lines are parallel? That's a trapezoid, okay? And that is going to be very important in a minute, all right? So let's say that this piece right here is 8, this is 4, this is 2, I'm going to go X, 3, and Y, okay? And let's do the easy one first. What is true about the two triangles that I have drawn there on the board? They're similar. How come? Angle, angle. Which angles do you know are, okay, like this one right here? This one right here? Okay, this one is obviously congruent to itself in both triangles. So there's an angle. Okay? And then, right, and then since these lines are parallel, that means that this angle right here corresponds with that angle right there, so they're parallel as well. And so I have two angles in each triangle that are congruent to two angles in the other triangle. Therefore, the two triangles are similar. And what that means is that we now have a proportion that we can use to figure out what the sides are. Okay? So let's do the easy one first. What is what? Okay. Let's set up a proportion to figure out what x is. James, can you put that away for right now? I'm positive that you don't need your calculator at this point. Can you put that away right now?
Yeah.
Okay. What is a proportion that we could use to find out what x is? Say again? 8 over 4 equals x over 2. All right, so he took the top sides, top segments, 8 and 4, and compared them to the bottom segments, x and 2. Okay? And that proportion works because it is a side of a triangle to a side of a trapezoid, a side of a triangle, side of the trapezoid. Okay? So if I cross multiply and divide, then x comes out to equal what? 4. Okay? Now here's where the trick comes in. This is what you have to be careful of. Give me a proportion that I can use to figure out what y is. Okay, good. He said 4 over 3 equals, mysteriously, he came up with 12 over y. Okay? Why did you do that?
The whole side.
Right, because if I'm going to go 4 over 3, that's side of this triangle over this side of the triangle. So since these are both sides of the triangle, I have to compare them to not sides of the trapezoid, but sides of the entire triangle. Okay? So 4 over 3 does not equal 8 over y. Okay? Because this little piece, as Jake pointed out, is not a side of the triangle, it's just a trapezoid. Okay? So side of triangle over side of triangle equals the entire side of the triangle, or 12, over this side of the triangle right there, y. Okay? Does that make sense? All right. So there's an important distinction there that you have to understand. When do you have to add together and use the whole sides, and when can I just use the pieces? So do you understand the difference between the first one that we did and the second one? Janae? Ryan? I don't know what you guys are doing back there, but it has nothing to do with learning geometry, so stop doing it.
I'm not doing anything.
Okay. We're good then. Okay. Do you understand the difference between why the 4 over 2 and the 8 over x works, but why the 4 over 3 and the 8 over y will not? Do you guys understand? That's what I'm trying to teach you. I'm getting a lot of blank stares, a lot of people that aren't even looking at me. Okay, got a thumbs up from Andrew. That's good. Melvin, do you have any idea what I'm talking about? You don't need to lie if you don't understand, then tell me.
Out, but I think I got it.
Okay, this one right here, 4 over 2, 8 over x, is because we're going like a piece of the big triangle over a piece of the big triangle equals a piece over the big triangle and a piece of the big triangle. Does that make sense? Okay, the 4 over 3 is an entire side of the small triangle over an entire side of the small triangle. So that means then if I'm going to compare that, I need to use the entire side of the big triangle over the entire side of the big triangle. Does that make sense? Kind of? Okay. Let's do one more deal there, because then sometimes it gets a little crazier. So now what they're going to do, since you understand that, is they're going to throw this at you right here. And they're going to go, I won't try to make those look like they're parallel, because Janae said I don't have to. So I'm going to go with 3 and 4 and x and, I don't know, 12. Okay? So now if I want to figure out what x is, can I go 3 over 4 equals x over 12 in this case? No. Okay? Because this is the side of the triangle and this is the side of the triangle, so I need to use the entire side of this triangle over the entire side of this triangle right here. Okay? So give me a proportion that I can use to figure this out. 3 over 4. Nice, and that's the key, is to get the 3 plus x in there over 12. Okay? So this little side right here over this little side right here equals the entire side there over the entire side here. Okay? Now what do I have to do to solve this proportion, since it doesn't just have an x in it, it has a 3 plus x in it? Yeah, still cross multiply, so let's do the easy one first. 3 times 12 is 36. But then what happens when I cross multiply this way? What do I get? 12 plus 4x. Good, you have to multiply both the 3 and the x by 4. Okay? And then it's an easy equation to solve. I can subtract 12 from both sides. So 24 equals 4x. Divide by 4, and x equals 6. Okay? Alright? So, does that make sense then, the distinction there between the when I can just go this over this equals this over this, and when I have to use the whole side? Okay, the difference, Noah, that I kind of think of in my head is
why you have to do the 3 plus x.
Because I need to use the entire side of this triangle, because this piece that I'm trying to find is an entire side of the big triangle, so I have to compare it to the entire side of the big triangle. Okay? So if I'm going a piece and a piece and a piece and a piece, then I'm good. But if I'm going whole thing, I need to go whole thing. All right? Okay.
Okay, dude.
All right, do that. All right, so that's it. Then that's chapter 11. So like I said, we'll go over your questions on Monday. Review assignment. Practice test Tuesday. Test on Wednesday.